Hello, hello. Please get seated. I'll begin. Um, Hi, my name is Jake. I'm the founder and CEO of Mitosis, and I'm trying to introduce what Mitosis is. And Mitosis is an ecosystem-owned liquidity layer 1 blockchain with EVM compatibility inherited. So before we begin with, I'll just try to assume that like overall crowd doesn't know what mitosis is, and yeah, and today I'm gonna like introduce about like how mitosis started and the rationale behind why we're building mitosis and the overall goal of what we're trying to achieve. So let's start with the very obvious part here. So when the fundamental tech increases, I believe the number of chains will increase. Um, um, and when there's more chains, there's going to be more opportunities to where to allocate the liquidity. Let's dive into the point of view of here Pepe. So here's like a cute Pepe here. Pepe has like 15 different options on where to allocate the liquidity. And since Pepe recognizes that he can allocate liquidity everywhere all at once, he's trying to decide whether if he's going to allocate the liquidity on one of these options. So he chose one. Basically, he thinks the founder is awesome, so that's the reason why he provided liquidity. And but the real reason behind why Pepe chose this option one is because of the opportunity cost. And by meaning of opportunity cost of these, AKA these airdrop amounts. But what if there's like more chains? What if there's more chains and Pepe decides to change his mind? So the whole dynamics between the DeFi protocol and Pepe here, which is a retail investor, is something like this. So Pepe provides liquidity to DeFi, and DeFis are procrastinating the yields, giving out these points program. So DeFi thinks farmers are mercenary liquidity, and Pepe thinks it's really hard to gauge the incentives. So as an alternative, what DeFi chose is basically talking to an institutional Pepe. And what institutional Pepe can bring is basically a bulk liquidity with a deep liquidity from the kickstart. And then as a return, DeFi protocols are giving non-disclosed terms. And most of the times, I'm not saying like every deals, non-disclosed deals are bad. But it's in the most cases, non-disclosed TVL deals exacerbates the open market. So it often leads to kind of like a predatory deal where DeFi protocol are giving out like a non-vested token from the TGE, and then these like non-vested tokens are being dumped in the market. So mitosis starts with the cold start problem, where how to make this like whole dynamic better. We thought about building like an open market for liquidity, and for creating like a market, like by definition, what is like a market? Market is basically meeting the supply and demand and make it in a scalable form. So what's the supply here? The supply here is that Pepe wants to have an access of these exclusive liquidity deals, and the demand here is that the DeFi protocols wants liquidity with a time commitment. And so that's like basically what we think of as a basic form of liquidity market. And the thing that we've done is we created a vault. So this vault is basically deployed on many different chains that we support, and people can deposit their liquidity into the vault. And now we have these liquidity in the vault. What we did was talking to these DeFi protocols and essentially saying that, do you want liquidity? And most of the time they say, yes, I want liquidity. So we negotiate the terms and we get like a very better terms compared to the retail market. And then the vault provides liquidity to the DeFi. And then in exchange for that, we get exclusive incentives and distribute to the users. So it's like a basically simple diagram of how mitosis operates. And so these are the key metrics that we have achieved. So we have integrated 8 different chains, talking to 10 plus DeFi protocols. And from the TVL side, we have launched like 4 months ago, and TVL has been constantly increasing. It's kind of trying to reach like 30K ETH. And thank you. And from an on-chain user perspective, we have 70K, Discord on 100K, and Twitter on 150K. But I'm not here to brag about our metrics here. The thing that I want to kind of share is that we try to make this whole process to scale, but the thing that we learn is that we encounter some of these points that we need to kind of figure it out. So let's try to deep dive on what were the things, and it's 3 things. So for one is allocating liquidity in a decentralized fashion is really hard. So which means we have liquidity in the vault, and when it goes to actually deploying the liquidity into these DeFi protocol, and when we are simultaneously talking to 10 plus DeFi protocols at the same time, the extreme, the left side is that the based intern decides what to integrate with and how much liquidity to provide and when to pull out the liquidity. And the other end is decentralized governance decides everything. So the point that I'm here trying to make is that one is better than one is better than the other. It's something we need to choose in between. So when Pepe decides everything, it may be efficient in terms of allocating liquidity and also even more profitable compared to going through all these decentralized voting system. But we're building a decentralized product. We're not building an FTX. So when we try to build a decentralized product, there are things that we need to consider what should be decentralized and what not should be decentralized. And when you think about talking to all these DeFi protocols at the same time, the operation cost from the Mitosis team is increasing day by day. So now we're currently supporting 8 different chains, and imagine when we're supporting more and more chains. Imagine we integrate 20 different chains, and we're talking to 5 different DeFi protocols at the same time. Then it's basically 20 multiplied by 5 is 100. So it's we're talking to 100 DeFi protocols at the same time, which is kind of non-scalable in the term of the operation cost. So we need to find a way to how to make it scalable. And what if there are cases of losses? So when you imagine providing liquidity into DeFi, we often think about what the yields will be like and how are we going to distribute the yields to the users. But in the minor cases, when you provide liquidity into AMM, impermanent loss can happen, and also in sometimes smart contract risk might also happen. And then when the extreme cases, something like a rug pull might even happen. So we encounter some of these challenges here and try to make this scalable liquidity market. And here are the things that we thought we needed as a solution. So here's 3 circles here, and we need to find something in the middle. So the first thing is that we needed a unified hub for managing liquidity. And also, we need a scalable decision-making process of how to allocate the actual liquidity in the vault. And the third is that we need to build a risk tolerance system where even though the hack happens, the system should go on. So as a solution, we decided to build a Mitosis Chain, and many people might be curious, even in our community, kind of questions why are we building a chain? And I guess people might be curious on why we're building a chain, and let's try to dive in why we decided to build a chain. So the current UX of the vault is that Pepe here decides to provide asset on the Mitosis expedition campaign and provides assets on Optimism chain. And you receive LP asset on the Optimism side, which means if you provide liquidity on 8 different chains, you get these fragmented and siloed LP tokens on every different chains. As a solution, what we chose is to create a liquidity abstraction layer in between. So even if you provide liquidity in Optimism or Base or any kind of chains, you receive an LP asset that is unified in the Mitosis chain. So in the Mitosis chain, you only need to interact as a user to where to allocate the liquidity on these underlying chains. So first criteria matched here, and the second criteria is that creating a risk tolerance system. So what is meaning by definition of creating a risk tolerance system? let's say you receive these LP assets on the mitosis, right? And you decided to provide liquidity on blast. And the basic assumption that we need to kind of preserve is basically we need to maintain the one-to-one peg between the underlying chain and the mitosis chain. But what if there's a loss happening on the blast? Then it's essentially the basic assumption that we made will be harmed because we can't guarantee the one-to-one peg between the underlying chains and the mitosis. So as a solution, what we did was we divided asset into two trenches. One is a vanilla asset, which is similar to a bridge asset. The bridge asset means is that the underlying liquidity on the blast will be just locked as usual, but the ones who are opt into the mitosis ecosystem own strategy will be converted into a my form of asset. So let's say you have 1,000 USDC and you convert that 1,000 USDC into a my form of USDC. And it means basically the assets are being utilized into underlying chains DeFi, and the my USDC holders can vote on where to allocate the liquidity on these underlying chains. So what we envision essentially here is that forming a composability between normal USDC and my form of USDC will create a better capital efficiency in the market, and that is essentially why we're building a layer 1 blockchain, having an EVM compatibility, and on top of that, applications can build on top of mitosis as well. So it meets the two different criteria. The last thing is that the most important part, that we need to create a system where it's scalable in terms of making decisions. So I mentioned about the my form of asset has the voting power of where to allocate the liquidity. And we all know that pure democratic on-chain voting doesn't really work in the system. So we need to kind of create a system where you can delegate your voting power, but you need to have incentives for someone who holds the voting power. So the thought process was basically to try to make this voting power to delegate and have more scalability in terms of where to allocate the underlying liquidity. And what we did was creating a dApps on mitosis. And essentially, dApps capturing the liquidity equals capturing the voting power. So what it gives, let's say Init Capital, which is a lending protocol, decides to build on top of mitosis. And then they capture 10% of the TVL of my USDC on mitosis chain. And this essentially means that the Init Capital has 10% of the voting power on where to allocate the liquidity on these underlying chains that is lying in the vault. So it gives a certain amount of scalability in terms of whether if the user provides the liquidity, you don't necessarily have to vote every time. Instead of doing that, you can just delegate your voting power to the application on top of mitosis by providing the liquidity on mitosis chain. So that's why we're building a mitosis chain. And let's go through the whole process again. And we call this whole process called ecosystem on liquidity. And so depositing my USDC into mitosis is like the same experience where you get the LP assets from the mitosis chain, which is equivalent of unified hub for managing the liquidity. And by dividing into my form of USDC and having a vanilla USDC gives the risk tolerance into the system. Even if the hack of the underlying DeFi happens, the system maintains. And for having a scalable decision-making process, you can delegate your voting power to an app through providing liquidity into DeFi, where it gives scalable decision-making process in the mitosis ecosystem. So yeah, so that's all for today. And if you have any questions regarding why we're building a chain and why we're building a developer-owned ecosystem where applications can build on top of mitosis, come to me. I'll answer any questions. Thank you very much. Oh, By the way, we'll be launching our public testnet very, very soon. And we'll be launching a waiting list for public testnet. So the ones who are participating in IRL, you guys will be receiving in one email. So like we'll be like spreading out like 10 super passcodes. So keep your email inbox, and we'll send you an email. Thank you. Bye-bye.